Hi everyone, before we begin the presentation, there are a few prerequisites listed here. If you want to participate hands-on with the hands-on portion of the workshop, then you're going to need either Minikube or you can use the Kubernetes Playground on Katacoda. So here is a link here to install Minikube if you'd like to do that. Alternatively, the Kubernetes Playground on Katacoda you can access just by clicking the link. Below that, you'll see there's a link to the TKN command line tool. If you're using Minikube, you can go ahead and install that now. Otherwise, we'll do that as part of the workshop later. And if you would like to get the Tekton VS Code extension, we have a link for that as well. So I'll leave this screen up for a minute or two so you can jot down these links or open them in your browser, and then we'll get started. Hi, thanks for joining us for this hands-on introduction to cloud-native CI/CD with Tekton and OpenShift Pipelines. We'll be starting with an overview of what CI/CD is, and more specifically cloud-native CI/CD. Then we'll look at some of the Tekton concepts and OpenShift Pipelines basics before moving on to the hands-on lab. Before we get started, let's have some introductions. I'm Jan Kleinert. I lead the OpenShift Developer Advocacy team at Red Hat, and I'm really excited to present this workshop to you today. Joel Lord, who's also a member of the OpenShift Developer Advocacy team, will also be with us in the Q&A to help as we progress through the workshop and at the end with any questions that you might have. Let's get started. So the focus of this introduction to the workshop is going to be on CI/CD. So to introduce the topic, let's look at a definition. To define CI/CD, we took a look on the Red Hat website and found the following definition, which really kind of encapsulates what it's all about. CI/CD introduces ongoing automation and continuous monitoring throughout the life cycle of apps, from integration and testing phases to delivery and deployment. The acronym CI/CD has a few different meanings. The CI always refers to continuous integration, which is an automation process for developers. Successful CI means that new code changes to an app are regularly built, tested, and merged to a shared repository. It's a solution to the problem of having too many branches of an app in development at once that might conflict with each other. The CD refers to continuous delivery and/or continuous deployment, which are related concepts that sometimes get used interchangeably. Both are about automating further stages of the pipeline, but they're sometimes used separately to illustrate just how much automation is happening. Continuous delivery usually means a developer's changes to an application are automatically bug tested and uploaded to a repository, where they can then be deployed to a live production environment by the operations team. It's an answer to the problem of poor visibility and communication between dev and business teams. And to that end, the purpose of continuous delivery is to ensure that it takes minimal effort to deploy new code. Continuous deployment, which is the other possible CD, can refer to automatically releasing a developer's changes from the repository to production, where it's usable by customers. It addresses the problem of overloading operations teams with manual processes that slow down app delivery. It builds on the benefits of continuous delivery by automating the next stage in the pipeline. So now that we've established what we mean by CI/CD, let's talk about cloud-native CI/CD. Cloud-native is such an overloaded term, so let's talk about what we mean in this context. There's 3 items here: containers, serverless, and DevOps, and we'll talk about what we mean with each of those. For containers, it means that cloud-native CI/CD supports applications that run in containers and that are orchestrated by Kubernetes. For containers, it means that cloud-native CI/CD supports applications that run in containers which are orchestrated by Kubernetes. For serverless, we need cloud-native CI/CD to be able to run and scale on demand without the need for a central CI engine that has to be maintained and taken care of. And DevOps, what we mean here is that these CI/CD processes are built with DevOps practices in mind, and they allow teams to own their delivery pipelines alongside the applications without having to rely on central center of excellence teams that manage delivery pipelines on other teams' behalf. So essentially, we want to be able to build, test, stage, deploy everything with those characteristics in mind. And there are many options out there available for your projects to choose from. A few of them are Jenkins, JenkinsX, and Spinnaker. They're all good options, and you can find out more on them and others if you look at the Continuous Delivery Foundation, which you can find at cd.foundation. But the project we're going to be talking about today is one with a very cute logo, and it's Tekton. So Tekton is a powerful, flexible open source framework for creating cloud-native CI/CD systems. It integrates with Kubernetes and allows developers to build, test, and deploy across cloud providers and on-premises systems. If you look at all the existing tools, they all have some things in common. You have some inputs, like your code, you perform some task on it, and then you have an output, which might be an image that could be deployed. Tekton was built with these things in mind. It provides us with a set of tools that are composable, declarative, reproducible, and cloud-native in order to make it easy to build pipelines. Tekton adds a few CRDs, or custom resource definitions, into your Kubernetes cluster, and you can then use those pieces to put your CI/CD pipelines together. Let's take a look at those building blocks that Tekton provides us. First, we'll look at steps, tasks, and pipelines. A step is one of those operations that we perform on our code. Whether you're building a Java application, a Node.js application, or really any other type of application, you may be running unit tests or validating that the code follows the coding standards you have in place. Tekton will perform each step that you provide inside a container. Here's an example of a couple types of steps here. A task is a collection of steps, and within a task, the steps are performed in order. So Tekton runs tasks inside a Kubernetes pod that allows you to have a shared environment when you're designing a series of steps that are related. For example, you could mount a volume in a task that would be shared across each step in that specific task. Tasks are specified as custom resources in a Kubernetes cluster. A pipeline is a collection of tasks that can be executed in a number of different ways. In this diagram, the pipeline starts by running this task here. Then it will run these two tasks in parallel, and then once those have both finished, this final task will run. Tekton provides developers with a lot of flexibility on how and when tasks will be executed. You can even specify conditions that a task must meet in order to start the next one. Pipelines are also specified as custom resources in a Kubernetes cluster. So now that we can perform operations, we'll need something to operate on. And you might want to output something at the end of your pipeline. This is where input and output resources come into play. Each task and pipeline can have their own inputs and outputs. The nice thing about the reusability of Tekton pipelines is that once you write a pipeline for building, testing, and packaging an application, you can use that same pipeline with a different input. For example, you could use a Git repository as an input for your pipeline and an image as an output. And you could reuse that same pipeline for a different code base if needed. Resources can be of many different types, including Git repositories, pull requests, images, clusters, storage, cloud events, and so on. Resources are also defined as custom resources. And then finally, we have task runs and pipeline runs. And as the name implies, they're specific executions. A task run is the specific execution of a task. You can run tasks outside a pipeline to help you see the specifics of a single task if you need to. And a pipeline run, similarly, is the specific execution of a pipeline. Your task runs and pipeline runs are also what binds together your tasks or pipelines with the resources. Those runs can be triggered manually, as we'll see in our hands-on portion of the workshop, or you can trigger them on demand using Tekton triggers. So a pipeline describes the activities that take place during the execution of Tekton tasks. Pipelines, however, don't contain the specifics of Git repositories, image registries, clusters, etc., in order to keep the pipeline decoupled and reusable across environments. These parameters are provided to the pipeline during execution through those pipeline resources. So during the execution, one could provide different sets of pipeline resources to execute the same pipeline against different Git repositories, different image registries, or different clusters. Now we're going to take a little bit of a look at OpenShft pipelines and what it adds on top of Tekton. OpenShft pipelines gives us Kubernetes native declarative pipelines that are built on top of Tekton. It gives us serverless CI/CD, so there's no single server to share and maintain. You can run your pipelines in isolated containers with all the required dependencies available. They're standard and portable to any Kubernetes platform. And then last but not least, you have access to interact with your pipelines using the web interface, command line tools, and VS Code and IDE plugins, which we'll take a little bit of a look at in a moment. Here's an overview of the OpenShft pipelines architecture. You can see here in the core piece, Tekton pipelines are a key ingredient to OpenShft pipelines. They're also bundled with the operator that installs OpenShft pipelines, extensions, integrations, and tasks from task catalogs. Then via the API, you as a developer can interact with OpenShft pipelines either via the web interface, the dev console of OpenShft, the Tekton CLI, code-ready workspaces, or Visual Studio Code using the extensions and plugins. So on top of Tekton, OpenShft pipelines makes the experience of creating and using and monitoring these pipelines easier. OpenShft Pipelines is easily installed via the OpenShft Pipelines operator. If you have admin access to your OpenShft cluster, you'll be able to find it in Operator Hub and install it on your cluster so that others can use it. For the purpose of the workshop today, I've already installed OpenShft Pipelines on the cluster that you'll be using, so you won't have to take this step. Here's an example of how you can monitor the progress of one of your pipeline runs in the web console. You can see here that the different steps and tasks are specified for you so that you can follow along. You can also view logs. You can do this via the command line tools, but it's also nice to be able to look at the logs directly in the web console. When you're creating a new application, when you're deploying a new application in OpnShft via the developer perspective, there's now an option to create a pipeline as you're deploying that application. This is a new feature in some of the recent versions of OpnShft. And then finally, here's a quick look at the pipeline builder, which allows you to compose pipelines using tasks from a task catalog. You don't have to use the web interface though. You can also create and manage your pipelines with the TKN command line tool. We'll take a look at that as we are running the workshop. And then finally, here's an example of what the VS Code extension for Tekton pipelines looks like. It's very useful for viewing the pipelines and tasks and everything that you're creating if you're working in VS Code. All right, so let's take a look at what all of this looks like in practice. On this slide, you'll see the link to our tutorial instructions. I'll read it out to you. It's github.com/jan-kleinert/hands-on-tekton. We'll leave this up for a moment to give you a chance to open that in your browser. It's important to have this open because you'll be able to copy and paste some of the commands from the tutorial into whatever terminal you're using. Once again, that's github.com/jan-kleinert/hands-on-tekton. Okay, so once you're on this page, you'll see some instructions on the README, and that's what we'll be following along for the workshop portion. And that's what we'll be following along for the hands-on portion of our workshop. So as I mentioned at the very beginning, you'll need to either have Minikube installed on your machine, or if you don't have that, you can use the Katacoda Kubernetes Playground. I'll show you what that looks like here. If you click the link, it will open this Kubernetes Playground screen where you can click Start Scenario. And there will be two terminal panels. You can use the top one and test it out. I'm sorry, first you'll need to click this launch.sh command to create the cluster. It'll take a few seconds. Once that's done, you can click this command here to make sure it's working. And if so, then you're good to go. And all the commands that we'll be using in the tutorial, you can paste here into this window. Alternatively, if you have Minikube installed locally, you can run that using the terminal on your local machine. I'll be using my terminal on my local machine for the purposes of the workshop, but either one of these will work. You will also need the TKN command line tool. So let's go ahead and open that in a new tab. Find the instructions that match your operating system. So if you're using the Kubernetes Playground for Katacoda, you're going to choose the Linux AMD 64. You can copy these and just paste them into that top command window and hit enter. If you're using a Windows machine, to load the Katacoda site in your browser, you may need to do Control-Shift-V in order to paste. But I'm running locally on my Mac here, so I will grab this command instead. install tkn. It's going to ask me to authenticate. Okay. Now if you type tkn version, you should get back version 0.12.0. All right, back to the tutorial. I already have Minikube up and running. If you haven't started Minikube, go ahead and do that now. And then what we'll do is install Tekton on your cluster. So whether you're using the Kubernetes Playground in Katacoda or Minikube, copy this command here, which when you run it will install Tekton on your cluster. It'll only take a few seconds. And then when it's done, run these next two commands. What we're going to do here is clone this repository that we're working on and then go into that hands-on Tekton directory. Oops. I do not have it anymore. Copy. Okay, so confirm that you're in that hands-on-Tekton directory, and then we'll move forward. First thing we'll do here is create a Hello World task. First several sections of the tutorial are working on very Hello World types of tasks and pipelines to help demonstrate the concepts. And then at the end, we'll look at more of a real-world example. So as we talked about in the presentation, tasks run inside a pod, and you can use them to perform all different kinds of CI/CD operations like compiling code or running unit tests. For this first task, though, we're going to use a Red Hat Universal Base Image and just echo a Hello World message to the terminal. So we have some demo files in our repository here in this demo directory. So I'm going to cat this first one so you can see what it looks like. It should match the task that you see here. Demo -hello.yaml. And so you can see that we're showing each of these files above the step, so you can see what we're going to be running. But if you want, you can also look at the files directly in that demo directory. So let's try this out. You can copy and paste into your terminal if you want to avoid any typos. kubectl apply -f demo 01 hello.yaml. That's going to create that task. And then we can use the tkn command line tool to start our task. So tkn task start, and then we pass in the name of our task, and then we're using this show log flag to have it show us the logs as the task is running. Let's take a look at what this task is doing. It looks very similar to any other Kubernetes resource object. It has a kind, which is task in this case, has a name in the metadata. The name of the task is hello. And then in the spec, we have our steps. This task only has one step. The step's name is say hello, and it's going to run this command to echo hello world to our command line. So let's try it out. Paste that in and press enter. And within a few seconds here, we should get a response back. So our task run has started. It has this auto-generated name based off of the name of the task, indicating that it's this unique run of our task. Okay, and there's our output. So the output from the say hello step is hello world, which matches what we expected based on our hello world task. The task can also take parameters, and this allows us to pass flags or different options into a task. This is really helpful in making your tasks more generic and reusable across your pipelines. So let's modify the task that we started with to ask for somebody's name and then say hello to that person. So starting with our previous example, we've just added a param section here in the task spec. The param has a name, which is person, and a type, which is string. You can also add a description. We've called that name of person to greet, and a default value. we've used world as the default value. Then you can access those parameters using variable substitution. So you can see here in the args line, we are changing world to be, params.person. So let's apply that new task and then rerun our task. I'll paste this in with that 02-param.yaml file. And then let's run tk task start just like we did before, but now it's running this updated version of the task. So we're prompted in this case for a name of a person to enter. I'll type my own name. You can type whatever you'd like. So I'll tell it Jan. And then we wait for the logs. What I expect to see here is that it should say hello Jan instead of hello world this time. There it is. Now you can also pass in those parameters when you are running the task like this. So in this case, we're doing tkn task start, --show log, the -p for our parameters, and we say person equals Joel, and then specify the name of the task, which was hello. So in this case, we should get back hello Joel. Perfect. So in the last example, we had a task with just a single step, but tasks can have more than one step. So in our next example, we're going to change our task to use 2 steps. The first one will write to a file, and the second one will output the content of that file. The steps will run in the order in which they're defined in the steps array. So we'll start by creating this new step called write hello. Here we'll use the same base image as before, but instead of using a single command, you can also include a script as you see here, using the script parameter, followed by a pipe and then the actual script to run. In this case, we'll echo preparing greeting, and then we'll echo hello, whatever value is sent in the person's parameter, and we'll write that to a hello.txt file. There'll be a little pause after that, and then it will echo done. The second step is the say hello step. This will run in the same container, and it'll share the /tecton folder from the previous step. So in the second step, we'll use a Node 14 image and the file from the previous step. And we can run a Node.js script here as long as we specify the executable. So in this case, what we're doing is writing a script that'll output the content of that hello.txt file. So let's try this now. Let's apply the task. And then we'll run it. And let's see what happens. Our param, I'll give it my name. All right. So here we go. We have our write hello task. It says preparing greeting and done. And then the say hello task, which says hello Jan. Next, let's take a look at pipelines. Tasks are useful, but you'll usually want to run more than one task. Tasks should generally do one single thing so that they can be as reusable across pipelines as possible. For our next example, we'll write a generic task that will echo whatever it receives in the parameters. Let's take a look. Here's our task called say something. It takes in two parameters. One is say what, which is what it should say. Default is hello, it's a type string. Then there's also a pause duration parameter, defaults to 0, which is how long to wait before saying something. And then here's the step, which is say it, which is going to sleep for the amount of the pause duration and then echo what you've told it to say. So let's build our pipeline. A pipeline is just a series of tasks that can run either in parallel or sequentially. In our pipeline, we'll use the say something task twice with different inputs. So here's first task, which has a pause duration of 2, and it's going to say, hello, this is the first task. And then the second task doesn't have a pause duration specified, which means it will default to 0, and it's going to say, and this is the second task. So let's try that out. First, we'll apply that task. And now our pipeline. Note here that there's this task ref item that refers back to the say something task. And just to make sure that it's clear, that's the name of our task here. So with this task created in the system, the pipeline can then reference it. So let's run this pipeline now. Similar to how we did TKN task start, you can do TKN pipeline start, pass in the name of the pipeline, and as we always have been doing, we'll pass in the show log flag. So this is running our pipeline that consists of 2 tasks. Okay, so here we go with our output, but you'll notice that these came in the wrong order. The reason that's happening is because Tekton tries to start all the tasks simultaneously so they can run in parallel. This one had a pause duration and this one did not. So if you really need one task to complete before another one starts, you can use the run after parameter in the task definition of your pipeline. Let's take a look at that. We're going to create a new pipeline now called say things in order. So our first task is just like we had before, pause duration of 2, and it's going to say, hello, this is the first task. Second task is going to say, happening after task 1 in parallel with task 3. And here you can see this run after set to first task. So task 2, the second task, will not run until the first task has completed. Third task says happening after task 1 in parallel with task 2. And it also is set to only run after the first task is completed. So once this first task is completed, both of these will then be kicked off. And then finally, we have a fourth task that says happening after task 2 and 3, which is set to run after both the second task and the third task are completed. So we're going to apply this new pipeline. I'm going to clear to free up some space on the screen, and let's run this pipeline, the say things in order pipeline. It's taking a little bit of time here, but we should have our results soon. All right, there's our first task, as expected. Now, I would guess we would see the third task next, since it had a shorter pause duration followed by the second task, which had a slightly longer pause duration, and then finally that fourth task. All right, there we go. Now there's a note here that if you have the Tekton VS Code extension installed, you can also see a preview of the pipeline and the order in which each of the steps is happening. So let's take a look at that now. I do have that installed in VS Code. So we can click on it here, this little Tekton icon, and we can look at our pipeline. So we have this Say Things in Order pipeline, and we have all the different pipeline runs here too. See this new one. If I click this icon, you'll see a preview here with first task, then second task, and third task, followed by fourth task. So this can be a nice way of visualizing your pipelines. Next, let's look at resources. When you're creating pipelines, you're going to want to make them as generic as you can, so your pipelines can be reused across projects. In our examples before, we used pipelines that didn't really do anything interesting, but typically you'll want to have some input on which you'll want to perform your tasks. Usually this can be something like a Git repository, and at the end of your pipeline, you'll want some kind of output. It might be an image that you've built, and that's where pipeline resources can come into play. So in our next example, you're going to create a pipeline that will take any Git repository as a pipeline resource and count the number of files. So we'll start by creating a task. It'll look like this here, and it will have an input resources, which is where it differs from what we've seen before. So our task is named count files. It has an input resource named repo of type Git, the target path of code, and it has one step called count, which is going to echo out the number of files in the repository. Now we need a pipeline. This pipeline will have a single task, which will be the count files task we've just defined. You can see that here, and it references a resource of type Git. So to create that pipeline resource, you would create a pipeline resource object that looks like this. The name would be Git repo to match what you've specified up here. The type is Git, and then there's the params, and this is where you can specify a param of type URL and provide the URL of the Git repository that you want to use, and I'm using the one here for this project. So with all those pieces, you can apply the file to the cluster. Let's take a look at this file first, though. Mo07 pipeline resource. And the reason I want to look at this is because this one file has our task, our pipeline, and our pipeline resource all combined in one. So that's what we're getting ready to apply right now. So it created our task, our pipeline, and our pipeline resource. And now we can run it with tkn pipeline start. We're starting that pipeline called count. So we're prompted to enter in the Git resource we want to use. We'll accept this default here of our current repository. If you had multiple ones created, you could choose the one that you wanted to use. And we'll wait for that to complete. Okay, so it's returned 59 files in the repo. Now you can also run it like this, where you explicitly pass in the name of that resource. So let's see what's different about running it that way. And what's different is you're not prompted to choose the Git repo in an interactive way. It just uses the one you've passed in on the command line. but we should get the same results back. All right, there we go. We get the same response this time as expected. So at this point, I just want to point out that pipeline resources are still in alpha within the Tekton project. And the Tekton core team is questioning, they're not quite sure at this point whether they should stay in the spec or not. In the latest version of Tekton, workspaces were added to share file systems between various tasks in a pipeline. There is an example of a pipeline using a workspace in the demo directory if you want to check it out. Workspaces require the usage of persistent volumes and persistent volume claims, which are out of scope for this lab. But you can check out more if you want to learn about those. Okay, so we have looked through tasks, pipelines, and pipeline resources, but all focusing around these hello world types of scenarios. So that's not super useful for your day-to-day life. Let's look at a real pipeline. So in this section, we will create a pipeline that's going to run 3 tasks for a Node.js project. First, it's going to run a linter to make sure there aren't any linting issues in the code. Then it's going to run some unit tests to validate that the code works. Then, if both the linting and the tests pass, it'll create a Node.js image and push it to Docker Hub using S2I and Builda. So we'll start with an npm task. And we're going to make it generic enough that it can be used for the first 2 steps of the pipeline. Our task has 2 parameters right here. One for the command line arguments that are used with npm, which are the action, and the other to specify the path of the application inside the Git repository, in case it's not at the root. The task also needs an input of type get. This is going to be the Git repository on which you'll apply the npm commands. Then you need to add 2 steps to the task. First is npm install to get your dependencies all set up, and then you'll run npm with the action parameter. Now, thanks to that action parameter, we can reuse this task both for npm run test and for npm run lint tasks, taking advantage of that flexibility and reusability of tasks. Next, we'll be using this S2I Node.js task. This task is using S2I, or source to image, which you can learn more about here, and Builda, which you can learn more about here, to generate, build, and push an image from the source code that we're providing. This one's going to need a few parameters. So we'll need a username and password for the image registry that we're going to use. I'm going to use Docker Hub for this example, and you can generate an API token instead of a password so that you don't have to type your password. So I don't have to type my password here, but you all can see it. So we'll be doing that. And then you need an image name that you want to push to for the registry. The image gets generated by the Builda tool, and we'll have the name, whatever your registry is, so like docker.io/jkleinert/tekton-demo in my case. Then we're going to add the multiple steps required to build and deploy that image. So we need to generate our Docker file using S2I. S2I, if you're not, or source to image as it's called, if you're not familiar with it, it allows you to provide a Git repository, and it will infer a builder image to use, and then it will create a runnable application image, or in this case, we're just having it generate a Docker file for us. For our pod, we'll mount a volume that can be shared with the other steps. We'll add those at the end of the task spec. So then we're going to use Builda to build the image in the build step. And then finally, we'll use Builda to push the image to our image registry. So let's take a look at what that looks like. So here's our params in the S2I Node.js task. We've got user, password, image name, and registry. The registry is going to default to docker.io, but you could pass in whatever you choose. And it will take that input resource of type get. The steps are generate, which is going to generate the Docker file using S2I. Then we have build, which is going to build our image, and push, which is going to push it up to the registry. All right, for this last section, let's use the Kubernetes playground to mix things up a little bit. Since I haven't been working there before, I'm going to need this pipeline resource to be applied. You won't need to do that if you're working in the same environment you were in before. All right, so down here with our real world pipeline, let's try this out. Use that one. Kleinert is my Docker Hub username. I will grab an access token from account settings, security. I'll be sure to delete this when we're done. Paste that in. The image name is, in my case, is going to be tecton-demo. That's where I want to push this, and then we'll watch and see what happens. So let's start in here. Running npm install and npm lent, doing the testing. All right, now we're in that build step where we're using builda to build the image from the Docker file that was created by S2I. All right, getting close to the end of the build step here. And now we're in the push step, where we're going to push the image up to Docker Hub. It looks like that completed. If we hit refresh here, we should see that this was just updated a few seconds ago, so that's great. So let's try the next steps here of running this. So we'll do a docker run -d -p 2000, just typing what's here in the tutorial. And spawn Kleinert on. Let's make sure that's everything. Yeah, that's everything we should need. I can't find it locally, but it's pulling it from Docker Hub. Wait for that to finish. Okay, so that should be running now at 0.3000, so we can issue this curl command telling it to add the numbers 2 and 5, and we get back that result of 7. All right, so with that pipeline, we went from source code to creating a Dockerfile, to building an image, to pushing that image, and then we were able to use that to run this application. So everything we've done so far, we've worked with just using Tekton on kind of a standard generic Kubernetes cluster, either through this Kubernetes playground or through Minikube. So what we'll touch on next is a little bit of OpenShift pipelines. So you can get a sense for what that adds on top of the baseline Tekton experience. This next section on OpenShift pipelines will be primarily me demoing this for you. However, if you'd like to try it out, there's a couple ways you can do that. You can go to learn.openshift.com, go to the OpenShift playgrounds, and choose the OpenShift 4.5 playground. And from there, you can follow these steps. You'll need to install the OpenShift pipelines operator, however, first. But for now, my intention is to have you watch as I demonstrate some of the things we've already done with Tekton in the OpenShift pipelines environment. I've got a web-based terminal over here where I've authenticated to my cluster. And right now I am in the developer perspective of OpenShift. And you can see here that I have this pipeline options. The reason that this is visible is because I already have the pipelines operator installed by the admin of this cluster. If I click it here, you can see that I had already installed some of the tasks and pipelines that we had used earlier in the workshop. So let's take a look at that Say Things in Order pipeline. Similar to what you saw in the VS Code plugin, OpenShift pipelines will show you those tasks in a visual way so that you can understand at a glance what your pipeline is made up of. You can see the tasks, you can click into them, you can see the tasks, you can click into pipeline runs to see the different times that it's been run, click into that to see even more, and you can see the output, success or failure of each of those tasks. If I click on one of these, we can get the output as well. Let's go back over here to pipelines and try running one of these. We can run our count 1. Now this is interesting because you can see that it has a pipeline resource. So if we say action start, prompts us to choose a get resource, have the original source of the hands-on Tekton workshop here, so we can use that one and count the number of files in that repo. If I click start, you'll see the process of it here. So you can see that that task is running. If we want, we can click into it to watch the output, and we got that there's 63 files in that repo. For all of these things, you can also look at the YAML. So here's the YAML for our pipeline run, if that's something that you want to dig into a little bit deeper. But again, on the details page, you'll be able to see the outcome here. So OpenShift Pipelines also has a pipeline builder. So of course you can use the tkn command line tool just like we've been doing throughout the workshop. But if you prefer and you want to build these pipelines in the web interface, you can do that. So let's click Create Pipeline now. Let's put together a new pipeline, we'll leave this name here, that consists of that hello task that greets the user. So we have that task available here. You'll notice there were other tasks to choose from, but we're going to use this hello task. When I click on it, it tells me that it's expecting a parameter. Oops. And the default value for that parameter is world. We could also add another task after this one where we want to maybe count the files in a repository. Now this is giving us some kind of a warning that we need to take an action. Let's say we pick our Git resource. We have to add pipeline resources in this case first. So let's do that now. Select resource type of Git. I think we call this Git repo. Okay. And then we can select it. All right. So let's try this out. This is kind of a nonsensical pipeline to say hello to the user and then count the number of files in a repository, but let's try it anyway, just to see how the pipeline builder works. So we'll say start. It's asking us for the Git repo. We can use this one. And it's taking that default value for that parameter. This first task completed. And then when that was done, the second one was kicked off to count the files. And as before, we can watch in here. There you go, it's complete, 63 files. Okay, so now in this workshop, we've explored what is CI/CD, what is cloud-native CI/CD, some of the fundamentals and building blocks of Tekton, how to actually go through the process of creating tasks, pipelines, pipeline resources for both a Hello World style pipeline as well as a more real-world example. We looked a little bit at the VS Code extension for Tekton, and then finally I gave you a quick run-through of OpenShift pipelines. If you want to learn more, let's take a look at some of the resources that are linked from the bottom of the hands-on-tekton Git repository. So tecton.dev is the main Tekton website. It's a great source of information. Definitely recommend you check it out. Tekton Hub is pretty exciting. This is in preview mode, but this, I'll just go ahead and show it to you. This is a visual way of looking at a task catalog. So you can see a bunch of different tasks that you can use. You can click on them to learn more, as well as figure out how to apply those tasks. So this is a great way of finding tasks that you can use so you don't have to try to create everything yourself and reinvent the wheel. Next, there's this page, the CI/CD page on developers.redhat.com, which has lots of developer-facing info on CI/CD as well as Tekton. And then finally, there is an OpenShift Pipelines page on OpenShift.com where you can generally learn more about OpenShift pipelines, and it will link you out to the documentation as well. So I hope this workshop helped you learn more about CI/CD, Tekton, and OpenShift pipelines. There should be some time left in our workshop session, so Joel and I will be around to answer any questions you have. And if you'd like to continue experimenting, if you have any questions, we'll be happy to help as much as possible with those. Thanks so much.